In the next part that we are going to discuss is effects of corrosion, or not corrosion, we are going to study corrosion, but effect of oxidation reaction in everyday life. So we are going to study about corrosion over here. So again, we can have fancy definitions. So I try to always give a simple definition, but you can follow the fancy ones. That's up to you. But the real meaning of any kind of term should be clear in your head first. Then only you can make a good definition, or you can make some meaning out of it. And we are not supposed to change the sentences of definition when you're writing for exam. But if we haven't understood the meaning of that definition, then how we can remember it at the first place? Now, corrosion is degradation. It's you can say it's eating up of the metals, or it's getting the top layer of the metals is getting degraded over there. So corrosion is going to happen because of certain atmospheric gases which is present in the atmosphere, and they chemically react with the metals. So corrosion is definitely about metals that we are studying over here. So we can define it's a process of degradation of metals due to the attack of atmospheric gases like oxygen, carbon dioxide, hydrogen sulfide, even water on the surface of metals in order to convert into oxides, carbonates, sulfides, etc. So that is called as corrosion. So how we are going to study corrosion right now? We are going to do only three reactions as of now. We are going to study corrosion of iron, copper, and silver. And then we are going to study how to prevent corrosion of iron. And corrosion of iron is the most important one, and we even call it as rusting. So equations are most important over here. Now, rusting or corrosion of iron over here. First, we are going to write iron, which is in the solid state. It is going to react with oxygen, which is present in the atmosphere, and even water. That's moisture present in there. So this is a very slow reaction. It's it can take a lot of days, months, years also, and its surface will be covered with some brown flaky substance. That is what we call rust. Rust is actually a color, and this product will be formed Fe2O3 dot. We are going to take this variable number. Now x over here can be 2, it can be 3, whatever. So over here x is a variable number, and we call this as hydrated ferric oxide. Why hydrated? Because there is some loose bonding over here, x molecules of water which is there over here, and Fe2O3, hydrated ferric oxide. Fe2O3, you can figure it out why it is ferric, because over here iron is plus 3 and oxide we know that is 2 minus, and then we have to balance this. So water we are not going to touch, but iron is going to be 2 and oxygen is going to be 3 by 2. We can take the fraction over here. So water is moisture, and this is from air. So this is our rust. Brown, flaky, non-sticky substance. Then we go to the next reaction, that is the corrosion of copper. Now, copper usually doesn't, it definitely corrodes in the presence of oxygen and water vapor for sure, but we have one more gas which is going to add up, that is carbon dioxide, which is present in atmosphere. Carbon dioxide doesn't affect iron much, but yes, copper it is definitely going to participate, and it's going to form this product, CuCO3 dot CuOH whole twice. So this is called as basic copper carbonate, and this also is a ore of copper. We even call it as malachite. So malachite is an ore of copper. So ores are the minerals from where we extract metals industrially, commercially. So it's economical to extract metals from these particular minerals. Ores are just minerals like any other mineral, but these are special minerals, so we have given a separate name to them. That is what we call ores. Now it's a green color. Now we know that this was iron was rust. This is green in color. We need to remember, and if you have seen copper ornaments, after a certain period of time, if it's too much exposed to atmospheric gases, definitely it's going to change into some green spots will appear on the copper articles. That is the corrosion of copper. So this is from moist air, and copper is itself is we say it's reddish brown in color. So we need to balance this. This will be 2 solid in state. So rest is perfectly balanced. Gas, and this is going to be solid. Then we go to the last, that is for silver corrosion. Now, silver doesn't react with any of these, what we did over here, not with oxygen, not with water. It might react, but we can't write it in the chemical reaction because majorly it's not there. So, silver will react with H2S gas, which is present in air. Now, I told you it has rotten egg smell, but only in the concentrated forms. In the atmosphere, it's present in very trace amount. It's, I would say, very low percentage. So we are not able to predict, not able to sense that kind of rotten egg smell. It's only in the concentrated form. So if you have smelled this H2S in the labs, definitely you can imagine that it's very difficult to breathe in the presence of this gas. So this is present in air, and it's going to react Ag2S. Now, one question comes to our mind, and hydrogen gas is released. We know that this is, you can say, a very weak acid. We consider this H2S as a very weak acid, and we know metals can react with acids, but silver is somewhere very below in the reactivity order. So, how we can justify this? We can justify that this reaction is very slow. It's not going to happen in, you can say, within a minute, or it might even take months. So it is a very slow displacement reaction which is happening over here. But yes, it's a type of displacement reaction, and we are going to get silver sulfide, and this is very much black in color. So the black coating on silver ornaments. So so we need to balance it. This is 2, rest everything is balanced. Next, that we are going to discuss the methods to prevent rusting. So first, that we can say, we can paint it. You have seen boats. The bottom of the boats is always rusted. It has reddish brown coating on it, but they are that flaky substance. Even if we try to do a lot of paint or we try to do give best prevention, still some reddish brown deposits will be there at the bottom of the boots. So painting, the iron articles, any kind of window grills, iron gates, any kind of steel furniture also, railway coaches, then so many other things. Then we have by greasing or oiling the articles of the iron articles, so any kind of mechanical tools or machine parts. Then we have by galvanization. Galvanization is coating of surface of iron objects with a layer of zinc. So zinc is not going to corrode, it's going to form some compounds. So like zinc reacts with atmospheric gases, form some compound very much similar to this copper which we have written over here. So that protects the iron article itself, so it will just stop the corrosion process of iron. And then there can be many other methods, but we are going to discuss little because this anybody can do it, anybody can learn it easily. Now coming to the last part of this chapter, that is rancidity. So rancidity, we say that food has become rancid. So we define this as oxidation of fats so oxidation of food materials by oxygen, which leads to change in taste, odor of the food items. So if we have seen any kind of you could say snacks that we see in the grocery shop, any kind of chips, so there's always some gas in it. So we don't, people say it's air, it's not air, it's nitrogen. So they flush the nitrogen into those chips packets so that the shelf life of those chips can be elongated, can be more. Because if air is there, air will always have oxygen, so oxygen gas will react with all the food items or whatever chemical compounds are there in the food items, and they will start getting degraded because they are changing them into some other compounds which will become more toxic. So oxygen is always going to decrease the shelf life of food items. That's why we try to find some antioxidants. So this spillage of food, you can say, can be done by adding a lot of oils in it that can increase the shelf life of the food items, by adding some antioxidants. So we should not, you can say, consume any food which has become rancid. So after the definition of this rancidity, we just have to learn about the prevention of rancidity, like how we can, you can say, we can prevent the rancidity to happen at the first place. So preventive measures for rancid food. So we can only slow down. We can slow down the rancidity process. We can never stop it. Just remember that. So first we can add is antioxidants, and just remember, antioxidants are nothing but reducing agents. That can be a very good question, like what antioxidants are. They are reducing agents. Reducing agents, if you see, they are the ones which helps in reduction but itself gets oxidized. So you can say they avoid the oxidation of food items but they themselves are getting oxidized over here. So these are antioxidants which prevent oxidation. We have many. So we have first that we can say is nitrogen in the chips packet. Then we have BHA. BHA stands, it's an antioxidant commercially used that is called as butylated. It's an organic compound, hydroxy anisole. Then we have BHT, butylated hydroxy toluene. We can even have, you can say, some inert gases also sometimes in certain food items we can use, or certain areas also. It's not only, you can say, over here we are discussing food items, but antioxidants can be used in various other items that we use, even on the body, even, in various, you can say, things that we buy and use on day-to-day basis. Then second is refrigeration. That again slows down the rancidity process. So at low temperature, definitely the rancidity processes slow down or it's retarded. So this can be another one. Then we can store food in airtight containers. Again, this can slow down the process. It's not going to stop it. Then another one that we can write is keep the food items away from sunlight. That can again slow down the process, but it's never going to stop it. In the last, I'm going to write some certain more reactions and some radicals, just add on information. So I want you to try balancing of these because I'm not going to give the answers for the balancing. This is cadmium carbonate and it's changing into cadmium oxide and carbon dioxide. This is actually a type of decomposition reaction. We can use one more example, lead hydroxide. It's again solid and it's going to change into PbO and water. So these are decomposition reactions. Some more examples I'm writing. Then we can take this example also. N2O4 dinitrogen tetroxide, which is in the gaseous state, changing into NO2 again in the gaseous state. We can take this example. So you have to balance all this. I'm not going to balance, this is your homework. PCl5 phosphorus pentachloride, solid in state, changing into phosphorus trichloride along with chlorine. Carbonic acid in the aqueous state, changing into carbon dioxide gas and water. We can take Ag2O, changing into silver and oxygen. Then we can have these some reactions, some more reactions for balancing. FeS2 reacting with oxygen to give Fe2O3 plus sulfur dioxide. You have to balance these. PbO, PbO2 reacting with HCl, giving you PbCl2, chlorine and water. Phosphorus reacting with bromine and water, changing into phosphorus acid, H3PO3 and HBr. Iron reacting with nitrous oxide, that is also called as laughing gas, giving us nitrogen and Fe3O4. Aluminium reacting with Fe2O3, giving us iron and Al2O3. Then we can have some double displacement reactions. So we need to balance these. So balance these chemical reactions, all of these. So double displacement reaction, we even call them as metathesis reaction. So PbCl2 reacting with lithium sulfate, changing into lead sulfate plus lithium chloride. Zinc bromide reacting with silver nitrate, changing into zinc nitrate. Plus silver bromide, AgBr. Barium chloride reacting with potassium iodate, giving us barium iodate. Plus potassium chloride. Then some more ions I'm going to write over here, just few of them. H2PO2 minus. This is called as hypophosphite ion. CNO minus. Cyanate ion. H2PO4 minus ion. This is called as biphosphate ion. Arsenate from the metal arsenic along with oxygen. Then we have aluminate. Aluminate we have already done. Then we have some complex ions that we'll be doing in acid bases chapter later on. So FeCN whole 6, this is called as ferricyanide ion. FeCN whole 6 with a 4 minus charge, this is called as ferrocyanide ion. So I will end this lecture over here. Thank you for learning chemistry along with me. And in every lecture, I learn something new while explaining so many stuff to different students. So I hope I was able to help you in any way in this entire learning process. Thank you so much.